This is a review of what I mistakenly did on the third question of the first fluid mechanics exam. So first of all, I'm going to go over how to correctly solve the problem. So in part A, we're asked to find a relationship between the change in the radius of this balloon with respect to time in terms of all these variables. And to solve this, you can set it up so that you find an equation for volumetric flow rate out of the balloon, and then also an equation for the volume of the balloon. Plug both of those into the relationship, which is the derivative of the volume with respect to time is equal to this volumetric flow rate going out of the balloon. And once you plug in, you can solve using the chain rule to find the derivative of dr dt cubed, and then plugging all that back in, you get this relationship for dr dt. And so I was on the right path, and I do think that my solution could have worked, but this is a much more about way of getting the answer than this direct method right here. So I have the correct relationship between flow rate out and the change of volume of the balloon, but then I ended up with R, and then trying to differentiate both sides with respect to time, and then solve for dv dt, and then plug back in what dv dt over here, which is much more complicated and convoluted method of getting the correct. I'm still not sure if it would give me the right answer, but I believe that it possibly could. I just made some mistakes somewhere in the line around here. Okay, so moving on. This one is finding the equation for R of t, and this should be a simple integration problem. I'm just in the head for not getting it correct. The reason I didn't solve it correctly is because constant term and put it on the outside of this cube root when that does mathematical sense, and it should be on the inside. And so I got the wrong term for R naught. And this makes sense because when you do an analysis later on, it doesn't turn out right if you have it on the outside. And so the correct, or actually no, it does, but I'm not sure. But the method of doing it is keeping the C1 term on the inside and then plugging in your known value, which is the radius is R naught at time equals 0. And so that's the correct equation. C, I went through and I solved this correctly, but I got up here, which carried on my issue from part B down here. And so if you solve it using the correct answer, you do get the right answer, which I don't know if my face is hiding, but which is TF 16R cubed 3D squared D out. So I got part D correct, so I'm not going to go over that in this video. But yeah, that's my